Richard Feynman, revolutionizing quantum electrodynamics and science education. Welcome back to our channel. Today, we're diving into the remarkable contributions of Richard Feynman, a towering figure in the field of physics, known for his groundbreaking work in quantum electrodynamics, QED. Feynman's innovative ideas transformed our understanding of how light and matter interact, and his unique approach to teaching science made complex concepts accessible to everyone. His work not only earned him a Nobel Prize, but also left an indelible mark on both theoretical physics and science education. So who was Richard Feynman, and what were his key contributions? Let's explore his life and legacy. Richard Phillips Feynman was born on May 11, 1918, in New York City. Growing up in a Jewish family, he displayed a keen interest in science from an early age. His father, a schoolteacher, encouraged his curiosity about the natural world, while his mother instilled a love for learning. Feynman excelled academically, earning a scholarship to attend the Massachusetts Institute of Technology, MIT, where he studied physics. After completing his undergraduate degree at MIT, Feynman went on to pursue graduate studies at Princeton University. During World War II, he contributed to the Manhattan Project, where he worked on developing the atomic bomb. This experience exposed him to cutting-edge research and laid the groundwork for his future contributions to theoretical physics. Feynman's most significant contribution came through his work on quantum electrodynamics, the theory that describes how light and matter interact at the quantum level. Before Feynman's contributions, QED was plagued by complex calculations that often led to infinite results, making it difficult for physicists to make accurate predictions. In 1949, Feynman introduced a revolutionary approach that simplified these calculations through the use of Feynman diagrams. These diagrams provide a visual representation of particle interactions, allowing physicists to easily calculate probabilities of various processes. By representing particles as lines and their interactions as points where lines meet, Feynman created a powerful tool that transformed how physicists approached quantum mechanics. Feynman diagrams are more than just illustrations. They encapsulate complex mathematical relationships in an intuitive way. Each line represents a particle traveling through space and time, while vertices indicate interactions where particles exchange forces. This visual language allows physicists to perform calculations systematically and efficiently. For example, when calculating the probability of an electron emitting a photon, a particle of light, physicists can use these diagrams to visualize all possible paths the particles could take during their interaction. This method drastically reduced the complexity involved in QED calculations and made it easier for scientists to understand fundamental processes in quantum mechanics. One of the major challenges in quantum electrodynamics was dealing with infinities that arose during calculations. Feynman's work on renormalization provided a systematic way to handle these infinities by redefining certain quantities in a way that made physical sense. Renormalization involves adjusting parameters like mass and charge so that predictions match experimental results without leading to nonsensical infinite values. This breakthrough allowed physicists to make accurate predictions about particle interactions and solidified QED as one of the most successful theories in physics. Feynman's groundbreaking contributions did not go unnoticed. In 1965, he was awarded the Nobel Prize in Physics, sharing this honor with fellow physicists Shinichiro Tominaga and Julian Schwinger for their work on quantum electrodynamics. Their combined efforts established QED as a cornerstone of modern theoretical physics. Feynman's acceptance speech highlighted not only his scientific achievements, but also his passion for understanding the universe. He famously stated that the most important thing is not to stop questioning. emphasizing the importance of curiosity in scientific inquiry. Beyond his scientific contributions, Richard Feynman was also renowned for his unique approach to teaching. His philosophy centered around making complex ideas accessible and engaging for students. He believed that true understanding comes from being able to explain concepts simply. Feynman's teaching method has been distilled into what is now known as the Feynman technique, a four-step process that encourages deep learning. Choose a concept. Select a topic you want to understand better. Teach it to a child. Explain it in simple terms as if you were teaching it to a child. This forces you to clarify your understanding and eliminate jargon. Identify gaps. Review your explanation and identify areas where your understanding is lacking. Simplify and organize. Refine your explanation using analogies or simpler language until it feels clear. This technique has become popular among educators and learners alike because it emphasizes active engagement with material rather than rote memorization. Feynman's influence extended beyond traditional classrooms through his famous lecture series at the California Institute of Technology, Caltech. These lectures were later compiled into the Feynman Lectures on Physics, which have become classics in science education. Through humor, storytelling, and vivid imagery, Feynman captivated audiences while explaining complex topics such as electromagnetism and quantum mechanics. His ability to connect with students made him not just an exceptional physicist, but also an extraordinary educator who inspired countless individuals to pursue careers in science. Feynman's impact transcended academia. He became a cultural icon known for his charismatic personality and love for science. He appeared on television programs like The Tonight Show with Johnny Carson and participated in educational documentaries that brought science into popular culture. His approachable demeanor and engaging style helped demystify physics for the general public, making him one of the most beloved figures in modern science. Quotes like, "The pleasure of finding things out," encapsulate his enthusiasm for discovery and resonate with anyone who has ever been curious about the world around them. In conclusion, Richard Feynman's contributions to quantum electrodynamics revolutionized our understanding of light-matter interactions while reshaping how we teach science. His innovative approaches, such as Feynman diagrams and renormalization, have left an indelible mark on theoretical physics. Moreover, Feynman's passion for education continues to inspire generations of scientists and learners alike. His emphasis on curiosity, clarity, and engagement serves as a reminder that science is not just about equations. It's about exploring the wonders of our universe. Thank you for joining us today. If you enjoyed this video or have any thoughts, please leave a comment below. Don't forget to like and subscribe for more.